I saw the future last week, Luke. I saw it. I was listening to Nvidia's earnings call, as one does, and then something hit me. Something just clicked, and I realized, oh, that's how AI is going to change the world. And that's why it hasn't really yet so far.
Okay. I'm intrigued.
There's just a lot of fuzzy definitions around what AI is still at this point. And I think a lot of people still imagine this kind of upcoming or in progress AI revolution as progressively smarter chatbots. These models we're all used to from OpenAI or Anthropic or Google or Grok, they're just getting smarter and smarter. And eventually they're going to get to this point where they're just going to know everything and more. Nvidia had their earnings call last week, and they were talking about something that was much bigger, but also much less glamorous. I think it comes down to really one thing, and that is infrastructure.
Okay.
What do you think? Is that what you were expecting?
No.
Sound exciting?
You have to connect some dots for me here, Joe. Yeah, I'm not don't totally follow, but yeah, I'm getting it. So it's not the models. It's not the models, it's the power plants. There it is, Joe.
That's exactly it. That's it.
Connect some lines for me here, Joe. Take me there. I'm on the garden path with you. Lead me to the way. Lead me the way.
So it was a two-part thing. It was like I was listening to this earnings call. I was listening to Jensen Huang outline his outlook for the future, his outlook for Nvidia. So who better to listen to than the guy building the future here? Oddly enough, I kind of accidentally started building out a primitive version of this infrastructure over the past few months in my little AI project. I got this DGX Spark, coincidentally from Nvidia, started running some local models. And the more that I experimented with it, I had like a kind of a grand, far-reaching project that I'll get more into. But the more I experimented and try to figure out how to do that, the more I realized that the hard part of making a really cool AI model to get something done, it's not a super smart model in itself. It's the harness that's wrapped around it.
Is that the infrastructure?
Yeah.
Okay.
Are you familiar with that word harness?
I guess not in an AI context.
Yeah. I think it's a relatively new term.
Okay.
I guess just to kind of ground it up front, Jensen Huang said directly, harnesses are agents.
An agent is essentially what people call a harness. Claude Code is essentially a harness around Claude. And these harnesses provide for things like I/O, orchestration, memory management, tool use connected to tools, for example, browsers and things like that, C compilers, Python compilers.
So it's like whenever you hear people talk about agents, it's kind of like a mysterious thing, right? But if I were to ask you today, people talk about, using agents to build a trading model, using agentic workflows to get some project done. What does that mean to you? Like, what is an agent?
I mean, I see it like you give a AI model like its own computer, and you give it a Windows operating system, and you give it email, and then you ask it to do stuff, and it goes from, I don't know, just acts like a person, goes from email to looks up the files that it needs to in some sort of shared drive and pulls it down and reads them, and I don't know, drafts an email, writes it to whoever it needs to, looks at the company directory, who do I need to talk to for such and such, and like does it just like a person would. That's what I thought an agent would.
Pretty much. So, okay. But how does an agent know how to do that?
That I have no idea.
How to do those things. That's the harness.
No idea. Okay.
So I don't know where the word harness came from, but the more I think about it, the more kind of appropriate the term is. But before getting into more specifics about agents and harnesses and what the future looks like for AI, I wanted to set the scene a little bit in terms of what this means for some of these big problems in economics and productivity and global growth that we've been talking about quite a bit recently. So as time goes on, the 2020s decade is really shaping up to look a little more like the 1970s decade, just something that's continuously plagued by inflation. Even though thankfully it hasn't been quite as severe so far, to me, I think in the future that's how we're going to look back at this. The 2020s is this really annoying, persistent inflation decade. And like whenever I look back and think about it, they're really from kind of unique circumstances. But the problem was it wasn't just one shock that happened that was due to one thing. It was a series of shocks really over the past year, nearly every year, just one after the other. So starting with 2020, of course, we had COVID. Early 2022, we had the Russia-Ukraine war and the energy shock that came along with that. Into 23 and 24, we had the big immigration wave in the US. So this distortions in the labor market that broadly pushed up prices in real estate and many other sectors. Into 25, of course, we had tariffs and deglobalization. And now today, we've got the Iran war and the oil shock. So it's just one after the other over the past 5 or 6 years now. It's just inflation keeps getting hit. One of these supply shocks, it starts to pass, starts to come back down, but then we get hit with another. And here we are today. Central banks are just continually chasing these things one after the other. But the problem is central banks, of course, don't really have any tools to address supply shocks like this. So the best they can do is wait for them to morph into a demand shock, which is more damaging to the economy, at which point then they look to raise rates and get inflation back under control. So how do we get out of this? What finally is going to end inflation for us, Luke?
Is it AI?
Maybe productivity growth.
Oh, okay. More broadly, sure. Zoom out.
Yeah,
I got you.
That's kind of the going narrative. That's basically our new Fed chair, Kevin Warsh's whole thesis that he pitched in publicly interviewing to get the job, coming down very hard saying that we're going to be able to cut rates without inflationary pressures because we're going to have so much productivity growth due to AI. But how does that happen? How do we actually get there?
Yeah, that's a really good question. That's like a really good question. Okay.
This is the future that I think that I saw.
I'm ready, Joe. Lay it on me. I'm ready for this knowledge.
It was from Nvidia's earnings call. Once I started hearing Jensen Huang talk about this in a way that just seemed to line up really closely with the general approach that I've been experimenting with myself, I just thought like, all right, wait, I get it now. I finally understand that this is how you make an AI model actually productive. Up until this point, it's been all about the hyperscalers, right? Just these frontier AI labs that are creating these models from the ground up. That requires a ton of computing power. Nvidia led the way with their GPUs, which fueled this whole boom that's still ongoing at this point. But what's the business line beyond the hyperscalers, beyond this small number of extremely power-hungry, GPU-hungry frontier labs? And he kept going back to what he was calling the second category of AI growth.
The second category is all of the AI native clouds. They're regional. They're all over the place. There are startups all over the world supporting those companies. They're enterprise, 250,000 enterprise companies around the world. Many of them will have to build or want to build AI factories for themselves to operate. Many industrial companies, there's no choice but to put the computer where the context is, where the action is. You can't put that in the cloud. It has to respond reliably, quickly, every single time. Can't imagine, a chip plant, a chip fab being connected to a cloud service provider. Doesn't make any sense.
the other point that he kept saying, the other term was on-prem. He kept saying on-prem compute. So basically, any other company, any other business enterprise, not just tech companies or AI companies, to meet that need, they're going to need their own in-house on-prem compute. So really what that means is you need your own thing. And this is where it started to hit me, because my AI experiments, I really didn't know what I was doing at the start. I just wanted to learn more about how models work. And I thought I wanted to do it in this slick way, but I want to control it. I don't want to make an API call to OpenAI or to X or whoever, hit the model and have them send something back to me. I want to have the whole thing end to end on my own computer, ideally even totally offline. So it's like something with complete information security. That was a very vague kind of first thing that I wanted to do, but it was enough. It was enough curiosity for me to go ahead and get started. So I did that. I bought this thing, started reading some papers, skimming through some textbooks, just trying to get a better understanding of how these things actually work. As I was doing that, I thought, all right, but I also want to build something with this. When do you build things that are actually going to have an economic impact in the world, whether it's at your job, whether it's building models, on your own time at home, like I'm doing here, whatever it is. So my initial idea was, well, I know there's all kinds of data out there, and whether it's stuff structured from the Fed, data feeds from Yahoo Finance, basic pricing feeds like that, or it's more unstructured stuff like speeches, Fed speeches, things, government officials' statements and speeches, and all kinds of different stuff like that. Government bond, auction calendars, all this different stuff. It's like I know what they all mean separately. You can read the speech, you can look through the auction results, you can go to the website and scroll through. But I thought, what I really wanted was I'm going to build this program, and I'm going to build a bunch of agents, and they're going to go out in the world. And like you were saying, they're going to, instead of checking an email and sending something back, they're going to go to all these websites. They're going to scrape all the data for me. They're going to save it down really nice. And then they're going to tell me what it says. They're going to, at minimum, point me to it, and then have some sort of consolidated summary view of it for me in some dashboard.
Yep. All right. Yeah, I mean, for those just tuning in, this has been a project you've been working on, or you mentioned it, or you teased it, I don't know, a month or two ago. More than that, maybe.
Thereabouts.
And I'm really curious to see what this means. And I know that when you say that this is like your AI model, you mean you bought the compute and you're training the model, like everything. It's not just, like you said, some sort of API thing. Like you have a separate computer, like a physical thing. Can we see it? Do you have a picture of it? It's just like a box. I don't even know what this thing looks like.
Yeah, it's just a little box. I'm considering if I want to just go get up and get it, because it's
I want you to
like
go get
big.
it. Yeah. Just go get it.
Yeah, all right.
Is it plugged in anything?
Let's do it.
What does this thing look like? No way. Let's see it. This is it.
Here it is.
That's the Nvidia thing. Okay, yeah, it's just like a little box, and you can
DGX
connect to
Spark.
it somehow.
That's it. You just USB-C, plug into power. That's it.
Wow. All right. How do you talk to it?
It just sits on my desk now, and then I had to learn some of the networking stuff to get it set up. But you SSH into it. You basically, so I use my laptop and remotely control it via my laptop. So it's like, it's not even connected to a keyboard or monitor or anything. It just sits on my desk, always on, and it does whatever I tell it to. So it's like I could issue it commands to say, do this continuous web scraping, go back every 5 minutes and check this website.
And how do you do that? Is it code? So you got to code into it? Okay.
Yeah.
What's the coding language?
Anything you want, but Python is what everything's
Python's the one you
in
use
today.
Okay. Okay, interesting. And how many lines of code would you think you've got on that thing running? Are they like separate? I guess like when you
Yeah, so you build. I've probably got well over like 10,000 lines at this point.
wow, all right.
I've got, but it's like I'm going kind of like the first part was a really, kind of basic synthetic toy model, or I'm just was like running
Yeah, right,
things
right, right. You got to
and
take tiny little
measuring
baby
them, and
steps, sure. Yeah.
exactly, yeah.
I remember I think we've all made macros here.
Yeah,
Copy
exactly.
something from this cell to that cell. Okay, it didn't break. All right.
That's pretty
Now
much
you
it
can
though.
do two cells.
Yeah.
Yeah. Sure. Got it. Cool. All right. That's really helpful. That's good context. All right. So you got the thing, you got 10,000 codes working. You're kind of playing around. You got a little more advanced and scraping websites, trying to see what this thing can do. When does it start turning from like code to actual like AI stuff? It's not just
Exactly.
like, yeah.
It's the vast majority of my time working with this. The vast majority is writing traditional computer code. Now I've got an AI model writing it for me, coincidentally, but there's no like the majority of the time it's not running an AI model. Like what makes this thing and like an AI computer is that one, it's got like their newest Blackwell chip in it, but otherwise it's just like a normal computer. So,
That's it. So the chip,
well,
the
the
chips,
GPU,
the GPU.
yeah.
So I mean, but the GPU, like when, like, um, okay. I mean, so far I can't tell. It's got a GPU that's running just code.
Yeah, I don't want to get too into the weeds of like what's doing what.
There is some like statistics. I remember there's like this funny cartoon where it's like AI and it's got a mask, and they lift the mask up and it just says statistics, and then the other guy's like, let's just leave this mask down.
Another point that Jensen Huang was talking about. So they're a GPU company. That's like their primary business, but part of their pivot is to be start making more CPUs as well. And just to really kind of basically sum it up, and because I don't fully understand it myself either, but the idea is that you use the really expensive high end GPUs to run these really huge computing intensive LLM models. That's the AI piece. Everything else around it, the harness, basically that's the thing that tells it what to do at every step of the way. That's traditional computer code that you can do it on your laptop from 10 years ago. That's your CPU. Just one
Okay,
other distinction.
so that's big. That's a piece that kind of gets dropped in. So when you're playing with this thing, when does and you've been writing the computer code, when does something like you give it a task or something, when does it like transfer over from the code to like a AI process, a GPU process? Put it a different way, why do you need a GPU in that thing and not a CPU? How much was it? Can I ask?
It was like $4,000. I mean, you could just Google it, but yeah, it was like $4,000.
Wow. Okay. Yeah, that was expensive. Okay.
Yeah, so it was like a solid investment. It was like
Yeah, that was
if I'm
investment.
gonna buy
Okay.
this
Very.
thing,
You could buy a really powerful like gaming computer for 4,000.
exactly, yeah.
Yeah.
So
Okay.
that was like a part of it. It's like, well, I want to learn what these AI models are. Everyone's saying AI is the future. Let me just drop some cash and commit
Yeah.
here.
Right. Okay. Are we going to see some
So
output today?
not today, unfortunately, but I'm getting
So
close. I
excited for
can I
this.
can I can
Taste it.
hopefully this will help set the stage a little bit.
Can you give us a little sneak peek of like kind of what's starting to? No, you were able
It's
to scrape a bunch of
I could
daily data, I guess, from news or something, and then it gave
I
you a
could show
summary.
you like my dashboard, but it's not updated yet for like the economic data part. It's still all set up for like the early.
That's all right. It's all right. All right. No
I don't
problem. No problem. No problem.
I don't want
It's
to
all
get
right.
too bogged down just yet because yeah,
Okay.
like when I do show it,
So you could just tell I'm a little excited. Okay. I'm just a little excited. All right. Go on. All right. Okay. So the harness, we got infrastructure. All right. You're practicing. You're working a lot of it's code, 10,000 lines, writing it yourself, plus, I guess, AI. Anthropic or something you got helping you out writing the code. It's still not clear to me exactly, what makes it AI and why not this isn't just a computer running code. That's still a question mark in my head. But okay, go.
So
That's a summary. What else we got?
yeah, so that's the harness. That's pretty much a computer running code, not a fancy AI model. The way I'm thinking about it now is the AI model is kind of like the brain. And in this computer code, which is a systematic workflow, it's a long, complicated chain of logic. Go do this. If this happens, go do that. If that happens, et cetera, et cetera. And you could just make it as complicated or simple as you want. The AI part is strategically choosing at which point along the way that you need a AI model to summarize, to interpret, to make some judgment call around this workflow that you've set up. So if you want to do a job, and this is how people have done it throughout history so far, and with computer code, you have to know all the rules of what's going on, to say the least. If you like, the computer only tells you as much as what you tell it to do. So if it hits something that you didn't tell it to do, it's not going to know what to do, and it'll do nothing. So the AI piece is, at those moments, you deploy the AI model, you tell it all the stuff it needs to know at that specific point. This process has been running for this long. It read these emails. Here they are. The data we pulled in is, here's the data that's relevant to those emails based off what the emails are asking and what the data says. What would be the most sensible next step in whatever business process or workflow this is? So it takes the traditional deterministic computer code, and it gives you little parts where you can kind of code in fuzzier logic. Like if GDP increases over this time period, then probably we're seeing a lower unemployment rate, but not always. But look at the data and see how well that holds. And point out to me some of the time periods where it looks like it doesn't hold as much. So that's something, for example, like you could never write into a Python script. It would just, you would just be endlessly trying to patch it with different, what if this had, what if that, blah, blah, blah. So that's where this, you strategically deploy the little brain, which is these, super smart models, all these things. Now they say they're at the level of PhD researcher in any field. So they're super general, but they're just that. They're very general. To do your job specifically, you've got a lot of accumulated knowledge and very specific experience that you've developed through the years. And to truly do your job, someone or something needs to know those exact little details along the way. And that's not something that's going to be trained into one of these models that is then deployed and used, generally. Does that make sense?
I mean, kind of, I guess. So I understand that was a good point about certainly when you're writing code and when the AI gets involved, it's like if there's more of a judgment call that needs to be made, that cannot just be deterministically code, if then that.
That's the statistics. It's instead of a deterministic decision, it's a probabilistic decision.
One. Yeah. And so I guess my next question, though, is because I'm still thinking about this in terms of the model that you have and that little computer that you have. And when you say like an AI model, and they talk about training it, it just means exposing it to a bunch of, data points from which it can extrapolate, like if this, then, or if it can extrapolate those statistics that it needs. My question to you is like, well, how are you training that thing? If that is in fact what you're doing, like, you know what I mean? At least like conceptually,
right, yeah.
They've got like, I know Tesla's got like a whole dojo. It's got like a gazillion hours or whatever of things. And like people are sitting there just like looking at screens and saying, this is a That's a car. That's a tree. It's another person. You just do that a gazillion times. Eventually, the model figures it out what a tree looks like. How would you do that, or how would like somebody in a company, if this is supposed to go local, how do you do that?
So that part is far beyond me at this point. Eventually, I'm hoping to get there, like deep into the internals of the model. But so what I'm doing today is I'm using open source, freely available models. So, for
Oh,
example,
you've kind of got like one of those plugged in or something, or can you download them?
exactly. So I have the actual model itself,
Oh,
which
and
is
you
just a
can
little computer program. And it's a collection of 7 billion weights, these little
got it. Yeah,
parameters,
yeah,
they
yeah.
all work
Okay, yeah,
together.
they talked about
And the
those.
secret
Okay,
sauce is what is that specific combination across 8 billion little nodes? And like
got
the
it.
frontier
Okay,
ones today, so that's like a really small one today. It's still
got
like
it.
super capable, but the ones at OpenAI, they're probably, a trillion parameters at this point. They're
Got it.
just
And
insanely large.
so, okay, so and you can like download one of those things and like and plug it in. So you download it, so it's actually on that little device, and it runs
Hmm.
those 800 or 8,000 or 8 million different weighted parameters, and then it gives you a decision for what to do. Okay, all right, that's helpful. I wish I kind of knew a little more about like how to translate like your specific code to like a model. That's a big question mark I'd have. It's like, how do you know which model to take, and how would the model know how to take like your code and interpret the decision point, the decision node or something? That would be a
Yeah, so
question mark
this
I had.
is this is a little more in the weeds of like, yeah,
Do
so
it.
like
Hey,
how
that's where
it's
we go,
written.
baby. Hey, we're all about details.
So I'm doing it really basically right now. I'm measuring the behavior of the models under different scenarios. So like some models are better at writing really nice prose. Other models are better at saying, looking at this data set, give me a structured JSON file that summarizes the data. So, for example, if you're along a workflow, one could be, okay, I want to web scrape this data site. One model, through experimenting, running thousands of models and determining, telling it to do very specific things and seeing how much it passes or fails, because again, these things are probabilistic. It'll never say the same thing twice. Well, that's actually not quite true, but there's it's doing random probability draws to get its final outcome. At specific points along the way, you choose the type of model that's best suited for that task in the workflow. So let's say I receive an email. Based on what that email is, I need to look up some data. Based on what that data is, I need to respond to the email. So the workflow could be like, okay, in my Python, I open my Outlook inbox. I read the top emails and I check, I'm looking for the one from this person or whatever. At that point, you could say, okay, read the email and now determine what we need to do.
And
And
this
it
is
could,
the code talking to the model.
yeah,
Okay. How many models would you have loaded in there so far?
I've been working with not a large number of them because I'm like trying to figure out how to
Sure.
measure them and profile them and stuff. But really, I'm just working with three.
Okay.
Meta, Facebook, they've got their open source one called Llama. I've got a big one and a small one. And then the French company, Mistral, they publish open source ones. So like, for example, like OpenAI and Anthropic, they don't make their models open source. Ahead of time, if you say, okay, now I understand the differences in which these different models behave, and you just simply do that by running them thousands of times and measuring them across different tasks, for example. So one prompt is like, write 2 sentences. The first sentence has 8 words, the second sentence has 12 words. And so and now you run it 1,000 times, and that's really easy to check. Just count the words. Did it get it right or wrong? Some models are really good at that. Some models screw it up all the time.
Okay. Got it.
It's true. Yeah. So it's like you start to
Yeah.
see like I don't know why that is, but I'm
Hmm.
like looking from the outside in. I can see that that's what it does, though, if that makes sense.
All right, I'm
And
with
then
you.
same thing, like my other example is like, given this data set, return a structured data object that then works really nicely with my computer code that then I can keep working with.
Okay.
So in
All
that
right.
email workflow, you could say, okay, now like read the email and figure out what it wants to do. Figure out what data source you need to look at to answer it. Okay, I need to go to, I don't know, this internal database or this website, whatever it may be. Then you ask another model, let's say, okay, now look up the data that I need and return just the relevant piece in a clean, structured way such that it can go back into the computer code and be read cleanly. And then you say, okay, now give me another model, or maybe the first one again, that's really good at writing a professional response, let's say. Then you say, here's the data, here's the very small piece of data that's relevant for this. Use just that and write a very narrow response to answer this question precisely.
Okay. I think I see where you're going. And you're describing through the code plus the various multiple models, you're describing all of them together is the agent, is the AI agent. The code half. Stop me when I say something dumb.
Yeah,
Just interrupt me. So the code half, that is the harness, the code piece, and that's something that you own. Like you wrote that. And presumably in the future, other companies will have to have their tech people or even just normal individuals. I will have to write the agent that is going to do my job.
exactly.
And then
And you don't need to know how to write computer code to do that, by the way.
you mean just because you can have like a separate AI code do it for you? You just describe what it is. I've had AI help me like with coding and stuff. It's pretty good, but the chunks that it'll give you is still pretty small. Like you got to put them together yourself. But that was a while ago. So I imagine they're a lot better now. And I have not tried using Anthropic, which apparently is the best. I think it's probably the best by like a lot. So, okay. So sure.
That's one of the other things Jensen Huang said, by the way. Harnesses are agents. And then he said, for example, Claude Code, that program, not Claude itself, Claude Code is a harness. It's a specialized set of software to make this advanced model do something more specific.
Okay. I gotcha. Okay. So like normal people like me, I'll be able to write the code. I'll be able to point to the right models that would kind of make those little inflection points that a decision needs to be made, and then automate essentially a good chunk of my job.
That's right.
And that in your view is what they mean by like, okay, that's going to be a huge productivity gain.
That's what's going to do it.
Okay. And that was your aha moment. How like, okay, I can finally see a translation between like productivity. Okay.
Pretty much. Yeah, because everyone's got, some version of Teams or Copilot or Claude Code at work now. But like one of the things I keep hearing is like, okay, great, this is really cool. I'll give it some, maybe broad question or even really specific question. Now it'll write me 8 pages of detail. Like, all right, great, but that's not really doing my job for me. It's educating me, which is very important, but it's not doing the job. You know what I mean?
Yeah, I know what you mean.
So you will have your own very specific instructions that you give to, some big number of AIs. So basically, like any workflow that you can think of now.
How about making a podcast?
That's kind of the idea.
Yeah.
Honestly, it's like, it's like you could, in theory, the other like key piece of this he was talking about in the earnings call is context engineering. That's the other big thing is context. It's all about context.
Okay.
And so context, it's just what you're telling the model. So like if your first thing you ask it is like, I'm 33 years old. What is the best kind of diet for someone my age? And then if you ask it something else later that relates to your age, it'll already know what it is because you previously asked it. That's it. That's context. And somehow context is saved differently in the model than, what it's trained with. That's the internals that I don't understand yet, but they're different things. You're not training a model when you just tell it something, but it does have some sort of memory. And again, this is beyond my uh, level of knowledge at this point. But that's really the key thing, and that's functionally how they work. That's how using Teams today works. If you copy and paste an email into the window, you say, "This is what someone said to me. How do I really politely tell them to get lost?"
Yeah, right. It's really good at that, by the way.
It's amazing at that.
Yeah, the LLMs are really good. Yeah.
So then,
Okay.
if you ask it a second question, it's going to know. Like then you could say, "All right, what's a good follow up email if they come back angry?" Which I know they're going to. It already knows what you were talking about before. And that was like a huge question in computer science that people couldn't crack throughout the 2010s. Like, that's the reason why we never had like a like subsequent Google searches. You couldn't say.
What was the problem that it couldn't crack? What was the problem that we couldn't crack?
You couldn't say, like, do a Google search, who's the president of the United States? I'll give you a name. How old is he?
It would
You
ask,
couldn't
like,
do
who?
that second one.
Yeah,
Yeah,
right.
because it's so in some way of its many big great breakthroughs, that's part of the super smart AI component. It now remembers these things. There's limitations to it, but it's far more vastly superior to what we were trying to work with in the 2010s.
Okay. So if you need like a concrete goal, I've got a request. If we wanted to automate something, it'd be like,
Yeah,
how do you come up with a good topic for us to cover?
that is what I'm working on.
Yeah, that's a good question. That's a perfect question. Okay,
And
good.
that's what I'm hoping to show you in 2 weeks.
Oh, cool. All right. Just constantly scrape and just be like, what's a good topic for us?
Where I am today is that I'm using I'm just focused on trying to come up with ideas. That's what I wanted to do. I'm not focusing on web scraping and all that kind of stuff yet. I'm going to do that, but the current piece right now is I'm just using Fred data. I just use an API call and I say, give me the twos tens curve, give me CPI, give me the 10-year treasury yield, give me GDP, just, pick a bunch of tickers. Do it over different data points, do it, and then so feed the model all of this data and ask it a question. You could say, summarize the current macro situation. You could say, based on where the data was 12 months ago, how would you characterize things differently if I asked the question 5 years ago?
That's interesting.
So what you can do, and so like what I'm working on currently is I'm going to ask it like a bunch of questions, a bunch of standardized questions up front. And the idea is most of them are probably going to be, not that interesting, just kind of matter of fact. GDP did this. We would expect this, but it didn't do. But my goal, like my measure of success of this first part of the project is if I can get it to tell me something and I can say, oh, I didn't quite think about it that way.
Right. Yeah, I think that's a good measure.
That's my goal right now.
Interesting. That'd be cool.
Yeah, so I'm working with just Fred data right now. I'm not expecting a whole lot just because it's, it's very common data. The next steps will be like, all right, now I'm going to take every Fed speech. Anytime a Fed speaker does something, you can't read all of them. But with this, you can say, every day, search every single regional Fed bank website, search every single government website, and take down every speech that was given. Summarize them all and translate that into data in a way that works well with the rest of my workflow.
Wow.
So then the further steps are going to be, then taking all kinds of different stuff like that.
Right.
So that's like my 2-3 steps out. I'm going to do the speeches thing. Then I'm going to do government bond auction schedules, because like I'm trying to think of things that are like really kind of niche things that you and I know about. You know what I mean? Through our, experience in the Fed, through our experience in our jobs. I think that's really where you and I we're like, we could get a lot of productivity gains in writing a podcast. And obviously, like a lot of this directly translates to just doing our day jobs as well.
Right. That's interesting, and definitely would be something, hopefully, that we're not just kind of repeating what we see sort of other people talking about, or even, it's interesting because I think one thing that we do or we try to do is, instead of just taking at the high level what people talk about, is we say, okay, people are talking about this. Let's actually dig down, get into the root, figure out like what the actual primary data source says. What you're proposing is almost like, hey, here are 100 different variables scattered across a bunch of things. Here's one way in which no one else is connecting them or making sense of them, but we are. So that's
Exactly.
a different. That's a very ambitious thing, I think, to do. That's like high level, macro analysis and stuff. That would be really cool.
Most of them are going to be,
Yeah.
common knowledge, right?
Right.
But
or they're just gonna. I mean, the question really, and I think what computers can obviously do way better than anyone than you and I can do, is the number of factors that can be held in their head.
That's it.
At one time. So like people, I think in the spoken word, you can only hold like maybe 5 different, I don't know, 3 to 5 different factors in your head. I think graphs are really powerful because you can multiply that and you can suddenly include, and a good graph could probably double that, like in terms of like the number of factors that you're considering in one moment.
Mm-hmm.
And I think that's why graphs are so powerful. But still, that's just like a huge limitation. If if like a computer can hold 1,000 different things, if it can see like, and then try to find patterns of like, if this rate goes up, that company stock goes down, this commodity price goes up over here, is that a pattern there's going to be amongst those thousands of things that people just like have never thought about or been able to see? Now, I don't know if your computer can do that, but like that's just an idea of what the potential
that's my goal
is huge. Yeah.
Mm-hmm. And so with this demo, I guess kind of last kind of concrete point. So like what I'm hoping to actually then show on screen, it's not going to be just like running this stuff. That's going to be boring. It's just like, terminals and executing code. But the output, I'm going to, run it a bunch of times. I'm going to generate a bunch of stuff, and I'm going to pick the highest quality things, and then we're going to read it together on screen.
I'm stoked. But can you also do me a favor though and show me the garbage output too? Just like give me
definitely.
Give me the full experience,
Definitely.
Like, what is this stuff? Okay, cool.
Mm-hmm. So then the other, like the agent part is everything we've been talking about, just like kind of directed specific use. Along with that is what I'm building into the end of it is, so I'm going to give it all kinds of data. I'm going to tell it to, ask it a bunch of questions about it. It's going to give me a bunch of responses. And then this is also, I think, what current AI use today is really missing is traceability, like auditability, being able to audit these things.
Yeah, right.
So as a part of the program, then I can then check just factually, does this statement line up with the data that I gave it? Because it screws up sometimes.
Yeah, you got to check
the big limitation. Yeah.
You even got to check like you got to check Grok too. And you got to check.
Exactly.
Yeah.
Those things are not perfect. By definition of being probabilistic, there is always a chance it could be wrong. Sometimes that chance could be super high. Others, and that's a future step that I've got further on the horizon, is you can check the actual probability distributions of when it chose to say this or that. So then you can effectively say, oh, it said this, but it was really uncertain, for example.
Oh, that's brilliant.
Yeah. That's a bunch of steps down the line. But
I was going to say, beats me how to do that. All right. Okay, cool. Yeah. No, that's exciting. Yeah, I'm really excited. You got an ETA? What do you think? How many more weeks?
Yeah, so I mean, I'm shooting for like my next round here. So like two weeks.
Cool, 2 weeks
from now.
Okay. Hey, look, we understand it's just the start. Just the start. You can show us some garbage output. I think it'll be great. It'll definitely provide much solid base. Right now, we're kind of all theory. If you actually like see this stuff,
I've got the garbage output right now. I'm at that point. The last step is.
What does it look like? It just comes out on your computer in like text.
Yeah, no, I mean, like you save them in data structures and then,
What's a data structure? What do you mean by that? Like a table? Like, what's the file type?
everything is typically saved in JSONs.
What is that?
Just a simple data structure that has keys and values. So you could say one of the keys is the
Oh,
CPI index. And then the values could be a single number, it could be a long list of numbers, it could be another JSON. So, you can very easily abstract these things and make them cover just about anything. There are other data structures out there, but that's kind of the just the standard that I've been working with right now.
so the output is all right. We'll look at this next time you come out. I typed into Google data structure with keys and values JSON, and it gave me an AI overview, and it gave me a JSON with some code like key 1 value, key 2 42, key 3 true null. At the very bottom it says use code with caution. Jesus,
That's right. Just like anything else, it's
dangerous.
yeah, like this use case is writing something, some kind of writing an idea down, something related to economics or whatever. It's the same thing with code. You can ask it to write me this code, but it can totally screw it up. So things like Claude Code built into it are these internal checks that happen along the way to try to reduce the probability of getting something that is garbage. And obviously these companies are really good with it. They've got many, extremely smart people optimizing that all the time, but that chance is always there.
Yeah,
And that's both the beauty and the problem with these things.
This reminded me of, it's like to err is human. To really fuck things up, you need a computer. And then it's like, what's that going to be like with AI? It's like to really screw things up, you need AI on the computer. Great.
But I guess back to the start here. That's what I think. That's how this is going to change things, because we're going to have full control over these things, so we can either screw it up way more or do 10 times the amount of work in half the time if we do it correctly.
All right, I'm excited. I'm stoked.
Full circle here. If that does happen naturally, then I really can see that as like a big disinflationary force in the economy. And that's what Musk means whenever he says we're going to have such abundance, we're going to have deflation. We're going to have so many things actually doing them beautifully. Right now, it can't really do the whole thing. We're like it's just at the very early days of writing the infrastructure to enable us to be able to do that with these models.
Okay, I see what you're talking about. Okay,
yeah,
and there it is.
And then so I guess final point I'll make, again, like just related to our conversations in the past, just like when does it get there? Like when we talked about robotics, for example, they're getting better and better. They're not there yet, but it's gonna get there, right? I think we both agree that there's some assumption along the way. And again, I think this is the answer. It's not going to be like the robot has this one AI model in it that is just so smart now. It's this just vast super intelligence. It's going to be a collection of just tons of tiny ones doing very small tasks, possibly very simple tasks, but all chained together in a very kind of general automated way. So the future is not a single, godlike super intelligence that's going to bring us AGI. It's going to be smarter and smarter systems that people gradually build using these really smart little brains placed really strategically along the way.
Okay, interesting. That's an interesting way to think about it. Never thought of it like that. But now that we got someone
that was my aha
on the
moment.
inside. That was your aha moment. Oh, brilliant. Cool. All right.
Good to know that isn't super obvious, because as I was like writing this, I'm like, is this obvious? Like,
it's amazing how fast that happens. One of the things, like, that's why from the beginning of the time I'm looking for like a topic to the end of it has to be a really, really short amount of time, so I can remind myself, so I know what it was like that I didn't know this. Like when I'm coming up with like topics for like what to cover, I'll be doing research and I'll putting together something that I want to write and talk about, and then I'll rewrite them and like, oh wait, doesn't everyone know this already? And it's like, no, I didn't know this yesterday. So I think it's fair enough to assume that maybe other people also do not know it.
exactly.
Some people know it for certain. but
Right.
I didn't know it yesterday. So, okay. Yeah, interesting stuff. I'm excited. Yeah, that's cool. I'm stoked. Yeah, I want to see what this thing looks like. I feel like I learned a lot about AI and what the F everyone's fucking talking about. But of course, nothing beats actually just seeing the, opening it up and seeing what's going on, like step by step, and just like what the output
Exactly.
would look like.
Because
So
it's all just abstract,
yeah,
like
like
that's,
keys and stuff. And maybe I should get that book you recommended about AI,
yeah,
so I could at least keep up with you a bit. Hey, man.
that's it. I'm excited too. Either way, this has been another episode of the Root of All Evil podcast. I'm Joe.
I'm Luke.
And we'll show you a demo in about 2 weeks.
Yeah, cool. All right. Talk to you next week.
See ya.